Hey, good day. I'm Jack Rusk, climate strategist at EHDD, here today to walk you through the use of the early phase integrated carbon assessment. This tool has been used internally by EHDD for about 2 years, and we're really excited now to open it up to everyone in a public beta, helping architects, engineers, portfolio managers, campus planners reach really aggressive time-based targets for reducing carbon emissions in the built environment. This tool and its development have a lot to do with EHDD's climate positive commitment. Through this, we've looked really seriously at how we do projects and which projects we do, committing towards reducing impacts from materials, maximizing energy efficiency, making grid responsive buildings, but also engaging in advocacy efforts, whether this is advocating for electrification adopted in code, or efforts like this, where we take internal work that we've done here on low carbon design and make it available widely to participate in a move in AEC to addressing the climate crisis with speed and scale. EPIC, as an early phase decision-making tool, fits into this part of the project where very little is known yet, actually, about the shape things will take. There's no BIM model. There's maybe not even owner's project requirements, right? And we're trying to set kind of a baseline and a standard or a set of strategies that can be used across the project to lower its carbon emissions. This could mean asking questions like, given a certain program from the client, is a retrofit or a new building better? Is it better to electrify or add PV panels or both? What is the specific location of the building in the country tell you about these strategies? For a long time, these early phase decisions have been made by best guesses, heuristic rules of thumb, but the complexity of the decision-making environment means that those decisions need quantitative support. And this is what the data model in EPIC aims to do. Cool. With that really brief introduction to the intentions behind the tool, let's move into its interface. So when you load the tool at epic.ehd.com and log in, you'll come to a screen like this that has a list of projects that you've saved previously. If you're new to the tool, you won't have any projects saved. Other things to note about the interface is that the big kind of pieces of it live on the left-hand tab. EPIC, in EPIC, you set a base case, a sort of a new building against which you will kind of compare the carbon reduction measures that you'll enter in this tab below. Once you have a set of carbon reduction measures that describes a potential strategy for reducing emissions from that building, you can save that as a scenario and compare between scenarios here. We have a mailing list that you can feel free to join here. And if you'd like to offer feedback on the tool, you can offer it by clicking here, linking you to a form. One thing that you'll see across the interface is these little circled information buttons. This one, the general one, brings you to the top level of our documentation for the tool. And when you see them throughout the tool attached to certain words, that'll give you more information about that specific choice or set of conditions so that you, as you're using the tool to plan carbon reductions, know what the tool is asking of you. Okay, so with all that said, let's start a new project. There's a warning when you start a new project where you have to affirm that you understand that EHDD can't predict the future, that this model is just a model, and I'll leave reading the rest of it to you. Agreeing to this notice, you can proceed to set up the base case. So here, let's call this a just climate positive office. Let's assume it's completed in 2025 in San Francisco, where I am now. Let's say that the kind of base case structural system for this sort of building would be a steel frame. And the office, it's the primary use is an office. That'll set the kind of EUI benchmark against which the design measures will be compared. We'll give it 4 above ground floors, each with the 1 below ground floor. Each of the above ground floors with an area of about 12,000 square feet, let's say 2,000 square feet in the basement to give us a nice even number of 50,000 square feet for our base case building. Cool, given all this information, I'll come down here and save the base case. It'll think for a minute and then generate the building, the sort of like shoebox hypothetical building against which the carbon reduction measures can be compared. There's a few other things here I didn't look at. One is a set of site and landscaping measures. Say, is it a greenfield site? Is it a brownfield site? How much site area was disturbed? What's the planted area in the base case? and a set of overrides. For instance, if you have an EUI benchmark set by code or by the campus, say, that you're working for on this project, or the owner in some other way, you can enter it here, and that becomes the benchmark against which you compare reduction measures. If there's another on-site fossil fuel combustion percentage that you'd like to look at, you can enter that here, and some basic attributes of the building. While we leave these open for the user to change, we also want it to be understood that the model is sort of calibrated to work with a certain set of conditions, and changing these criteria or these parameters too widely can lead to unrealistic results. I'm not going to mess with any of that now because I feel pretty good about where these baselines are. Great. So now that we have the base case set, we can look at some carbon reduction measures. In the carbon reduction measures tab, when you open it, you enter the measures and manage the scenarios on the left-hand side. On the right-hand side are these figures. This is cumulative carbon emissions over time. You can see that the embodied emissions in construction are present in each year. And as replacement periods occur for different elements of the building, it bumps up a little in those years. On top of that, the operational carbon emissions, the carbon emissions from energy use over time, accrue slowly as the carbon is emitted by the electrical grid or on-site combustion each year as the building goes on. There's another figure available here, clicking on this tab. It's embodied carbon by category that breaks down what's contributing to the embodied carbon in the building. You see here that structure dominates, envelope, interiors, and services like MEP. As we sort of add measures to this, the proportion of these things will change. Okay, but let's start looking at the emissions over time, and let's add some carbon reduction measures to this. First, let's add some embodied carbon reduction measures, and I'm going to name this scenario embodied carbon reduction. Let's just call it actually embodied carbon reduction measure, just for a shorter title. It'll take a minute to save. There's a lot of saving and validating that happens in the background as things change. Let's say as a first measure, we say that to the client, there's a way to maximize your existing assets and build a little bit less. This, according to the experts, is a thing we can do that's going to have the largest effect on reducing embodied and operational emissions, is building less buildings or building them more efficiently. So say we've come up with, I think we have a programming strategy to build 10,000 less square feet. That'll reduce the operational and embodied emissions from this project. Let's say that since this is a steel frame building too, we think it's really important that the steel specification is low carbon. We're going to specify the lowest carbon steel available in this area. And even for a project like this, concrete is always, is always part of it. We're going to specify low carbon concrete too. Let's see what we can accomplish by building a smaller building with better specified materials. You see how that starts to reduce the carbon footprint over time. Here, for instance, we see a net emissions, remaining emissions after those of about 8,000 tons and a reduction of 3,000. So this is a little less than a third of the total reduced, just with a smaller building and some better specification. That's great. You can see there's other embodied carbon reduction measures, say for envelope, for interiors, and for the refurbishment or replacement periods of those over time. And if you have questions about what these categories mean or might correspond to, you can click these information tabs and it'll bring you right to the information describing those measures. Okay, I feel good about this as one kind of scenario that we've set up. I'm going to save a new scenario by clicking New Scenario, and I want a new empty scenario. And in this new scenario that it's going to give me, I'm going to load in some operational carbon reduction measures. The first one being, let's say, to electrify the building. So as I scroll past all the embodied carbon reductions, here's an option to remove fossil fuel consumption for the building and see what that does to the building over time, to the emissions from the building over time. Further, and the EUI is 90 right now. Say we've looked at office buildings in this area and we think it's reasonable in this climate, with this set of conditions to set an EUI target of this building of 30. Think about it and make that reduction. And we're going to try see what the effects of some on-site renewables are. We're going to say, we can calculate it a bunch of different ways here, by the percentage of the total load, by the nameplate capacity of the array, or by the square footage available. let's calculate it by the square footage available. And let's say we have on this building that has, say, 12,000 square foot floor plates, on the ceiling, or the roof rather, about 6,000 square feet of area on which we can install a PV array. I'll think about it for a second and say that those 6,000 feet of solar can provide around 140 kilowatts nameplate capacity and deal with about 45% of the building's total energy load. Now I'll take this though, and this building's in a shady location. So there's a way just to assess a simple kind of factor for sub-optimal solar orientation. This is just a sort of fiat factor, but it helps understand like, well, maybe there's a, not every solar system is going to be the most high performing. And you can see how that changes the percent of load from PV. Okay, great. Let's save this as another set of measures and start a new one. For this next one, let's take a copy of the current scenario to start with the measures I just put in there. And we're going to add to it, we're going to say here, operational plus embodied carbon reduction measures. And here I'm just going to put back in the ones we put in before when we were just looking at embodied emissions. So let's say there's a 10,000 square foot reduction here. And low carbon specification of steel, or rather concrete and steel. And we can leave it there for now. So now that we've saved these three scenarios, let's see how they stack up against each other. Also rather here, actually, before we move on, let's look at, say, here's our operational embodied carbon reduction measures. Let's go to the embodied carbon by category. Here, we can see this scenario and the way things stack up here. You see interiors relatively, once we've done all these kind of reductions to the, to the structure and the specification for the structure, interior starts to take up a relatively larger proportion of the total. So, as one hotspot is dealt with, another always emerges. So let's just go to the scenario comparison and see how these things stack up against each other. All right, so we can look at operational carbon emissions. Note that, even if this is the embodied carbon reduction measures kind of scenario, lowering the size of the building also will have an effect on operational carbon. You can see here's the effect of those operational carbon reduction measures, and here's what they look like both together. And now we compare across four scenarios to see sort of like the trade-offs by category, but it's not only a category we're interested in, we're also interested in how these evolve over time. So here we can see the way these scenarios stack up over the 30-year period that EPIC looks at. We see the operational carbon reduction measures here, lower slope of the line, right? Because less energy used over time, but a similar starting point in the base case. And you see kind of the way that the embodied reductions translate the line down, and the, operational reductions change the slope of the line. And so great, another kind of tool for comparison. We see between the embodied carbon reductions measures and the operational carbon measures, this crossing point here, probably around 2035. This becomes interesting because maybe if there's a commitment to meet a goal by 2030, well, that'll look different with a set of embodied carbon reduction measures than it will with a set of operational carbon measures, and different again in 2050, right? So as like buildings and building owners are making these time-based commitments related to their emissions, we see graphics like this as a way to sort of like evaluate strategies, not only as static cases comparing quantities, but also to understand how they change over time. Cool, well, that's like the basic functions of EPIC, and now I'm gonna go through some of the other things that we didn't cover yet. We go to carbon reduction measures. So let's start at the base case. And let's see what it means to add some site to this project. If I say this building with a 12,000 square foot kind of floor plate is on 20,000 square feet of site, I'll think about it for a minute. And it'll assess a small penalty because it's not a previously developed site for the kind of carbon that's lost during the development process. I'm going to say it was a previously developed site, a brownfield site, and we're going to say that in the base case, there's 5,000 square feet of planted area. The assumption of the base case is that it's low sequestration planted area, turf grass, the like. And you see that we get a small sequestration kind of bonus over time assessed against the project. When I take this into carbon reduction measures, it'll take a moment. But recalculate the previously saved measures to include the new base case, updating them. Let's see what it means. I'm going to start in, like, let's make another one, a new scenario that's a copy of the current scenario. And this one will be called, let's say, embodied, operational plus embodied plus landscape. Okay, so once that saves, let's go down and let's add some landscaping to this project, some additional landscaping. So base case planted area, 5,000 square feet. You see that puts it first in the low sequestration planted site area. If you're wondering what these categories mean, click here, learn more. Let's say, for instance, if the base case is 5,000, we think we can add 2,500 more square feet of planted area to bring it up to a total of 7,500. We want to make, say, a third of this, say 33%, moderately sequestering planted area, things like shrubs or things local to the region that the building is in that have a higher sequestration potential, again, documented in the documentation. And we'll say 50% is high sequestration, perennial shrubs, trees. And then you see the sequestration potential assessed over time, pulling the net emissions line down. There's also the potential here to kind of understand the effects of sequestration, carbon sequestration in structure from biogenic materials. So here, for instance, let's change the primary structural system from steel frame to something like mass timber. We see the numbers change as that updates. Slightly lower emissions over time, just because there's maybe a slightly lower embodied carbon in the mass timber structural system. And we have this toggle for responsibly sourced timber. This is a really hot kind of topic of debate in the world of life cycle assessment and carbon accounting generally. We give our take on it in the documentation, but if you'd like to account for the sequestration potential in any structural materials, you have to make this commitment that you'll source the timber responsibly. What exactly that means, again, not totally settled in the literature, but an example of something that is a good place to start is FSC certification. So I click that toggle. In the first year of the project, it gives you a sequestration. And we see here that the sequestration starts, we start below zero, and then energy use and replacement periods keep us along that zero line as the project goes forward. So it saves automatically. Let's look at how this scenario stacks up. Okay, so there's just our embodied measures, the line offset down, our operational carbon reduction measures, the same, right? Starting with the same embodied, but then a lower slope line. If we look at both together, the lines both offset down and at a lower slope. And if we look at this last one, skirting along zero between now and 2050. So EPIC is a tool to set up these scenarios using a simplified kind of whole carbon shoebox model to make early decisions to bring to a client, to bring to a project, and to bring to consultants to set kind of directional targets and understand the way all these different measures interact with each other, trade-offs between them, et cetera. If you have feedback on the tool, things you'd like to see, things you'd like to be different, things that are missing in your mind, you click here. I'll bring you to a form where you can fill out all your feedback and receive updates by clicking here, adding yourself to the list. Thanks so much for watching this tutorial, and I look forward to hearing your feedback and your questions. Take care.